to Educator.com. Today we'll be covering solving systems of inequalities by graphing. In order to solve a system of inequalities by graphing, you need to graph the solution set of each inequality. So previously we discussed techniques, and you can review that lecture about how to find this solution set of an inequality by graphing. So here all you're going to do is graph each inequality, and the solution of the system of the inequalities put together is the intersection of the solution sets of the inequalities. So what this is really is the overlap, the area of overlap, the points that are in common between each of the solution sets. For example, if you're given a system of inequalities, y is less than or equal to x minus 3, and y is greater than negative 2x plus 1. Recall the techniques for graphing an inequality to determine the solution. First, you want to graph the corresponding linear equation to find the boundary line of the solution set. Then, use a test point to determine the half plane containing the solution set. So let's go ahead and do that and then talk about how to find then the solution set. This is just graphing each one, finding the solution set for each one. And then we have to talk about how to find the solution set for the system. So I'm going to start with this one, and that's y is less than or equal to x minus 3. And the corresponding linear equation would be y equals x minus 3. So this is in slope-intercept form, y equals mx plus b. So I can easily graph this because I know that the y-intercept is negative 3 and the slope is 1. So if the slope, since the slope is 1, increase y by 1, increase x by 1. Increase y by 1, increase x by 1, and on. Now, looking back here, this says y is less than or equal to. Y is less than or equal to negative 3. And what that tells me is that I'm going to use a solid line here as for the boundary line because the line is included in the solution set. So use a solid line to graph this. The next thing is to determine which half plane, the upper or lower half plane that the solution set is in. And I want to use an easy test point, and that's the origin, 0, 0, as my test point. And it's well away from the boundary line, so I can use that. If it was near or on the boundary, I would want to pick a different test point. So I'm going to take my test point, 0, 0, and substitute those values in to the inequality. So 0 is less than or equal to 0 minus 3. 0 is less than or equal to negative 3. Well, that is not true. Since that is not true, that means that the solution set is not in this upper half plane. 0, 0 is not part of the solution set. Therefore, the solution set is in this lower half plane. Okay, that is the solution set for this inequality. Now let's work on the other one. Here, y is greater than negative 2x plus 1. Corresponding linear equation, y equals negative 2x plus 1. So here I have the y-intercept at 1 and a slope of negative 2. So decrease y by 2, 1, 2, increase x by 1. Decrease y by 2, increase x by 1, and so on. Now, since this is a strict inequality, I'm going to use a dashed line because the boundary line here is not part of the solution set. Okay, so here is my line, dashed line. Next, I need to find a test point. And again, I'm going to use 0, 0. I'm going to use that test point. Okay. Actually, let's use a different one because that is a bit close. So let's go ahead and pick one that's farther away so we don't have any chance of causing confusion. Let's choose something up here. 2, 1. 2, 1 would be good for the test point. So my test point is going to be 2, 1. So I'm going to insert 2, 1 into that inequality. So 1 is greater than negative 2, x is 2, plus 1. So this is my test point. And 1 is greater than negative 4 plus 1. 1 is greater than negative 3. And this is true. Since this is true, that means that the test point is in the correct half plane where the solution set lies. So for this line, this is the upper half plane, and this is part of the solution set. So I'm going to go ahead and shade that in. Okay, so far I had just been going along doing what I usually do when I would find the solution set for an inequality. But remember, we're looking for the solution set for a system of inequalities. So this lower half plane is a solution set for this inequality. This half plane is a solution set for this inequality. Now, I'm looking for the intersection between the two solution sets, and that is right here, in this quadrant right here. Darken that in even more. And go ahead and use another color to emphasize that. Okay, so the area bounded by this line and including that line, that's the boundary line for the system of equations. And then the boundary line over here is the dashed line. So this line is not part of the solution set. So the technique, graph each of the inequalities, find their solution sets, and then find the area that is the intersection of the two solution sets. You may come across a situation where there is no solution to a system of inequalities. And this is because the two inequalities may not have any points in common. Remember, the common points in the solution set, in each of the solution sets, comprises the solution set for the system of inequalities. If the two inequalities have no points in common, then the solution set of the system is the empty set. For example, let's say I'm given y is less than x minus 4 and y is greater than or equal to x minus 2. So I'm going to go ahead and graph those, starting with y is less than x minus 4. I need to find the boundary line, so the corresponding linear equation is y equals x minus 4. So negative 4 is the y-intercept, and the slope is 1. So increase x by 1 and increase y by 1 with each step. Since this is a strict inequality, I'm going to use a dashed line. I have my boundary line. Now I need to use a test point. And I'm going to use this. The origin is the test point. And I'm going to substitute 0, 0 into the inequality and see what happens. This tells me that 0 is less than negative 4. And that is not true. Since that is not true, this is not part of the solution set. The solution set is actually below this line, the lower half plane. Okay, that was my first inequality. Now my second inequality, y is greater than or equal to x minus 2. Corresponding linear equation, y equals x minus 2. Here I have a y-intercept of negative 2 and a slope of 1. So increase x by 1 and y by 1 each time. Okay. Now, here I'm going to use a solid line. This line is part of the solution set. And a test point. I can use 0, 0 again. That's well away from this boundary line. Substituting these values into this inequality gives me 0 is greater than or equal to negative 2. And that is true. 0 is greater than negative 2. So this upper half plane describes the solution set. Now, you can see what happened here, and you may have already noticed that these two lines have the same slope. Since they have the same slope and they are parallel lines, that means they're never going to intersect. Since this solution set is above this line and this one is below the line, there's not going to be any points in common. These two lines will go along forever, and the points above and below them will never intersect. So this is a situation where there is no solution. We just say it's the empty set. So here we saw a situation where there's no solution because there are no points in common. Okay, first example. Very straightforward. X is greater than or equal to 2. Y is greater than 3. Starting with the x is greater than or equal to 2. The corresponding linear equation would be x equals 2. And that just tells me that if x equals 2, for no matter what the y value is, it's just saying x is 2. So that's going to be a vertical line. And since this is greater than or equal to, I'm going to make this a solid line. So a solid line. Now, you could certainly use a test point, or you could just look at this and say, well, it's saying that x is greater than or equal to 2, which means that it's going to be values to the right. You could certainly say, okay, I want to do a test point at 0, 0. 0 is greater than or equal to 2. Not true. So this is not part of the solution set. Or, like I said, you could just look back here and say, okay, it's telling me that the values of x are greater than or equal to 2. So this half plane contains the solution set. Second inequality, y is greater than 3, has a corresponding inequality, linear equation of y equals 3. So if y equals 3, that's going to be a horizontal line right here. And it's a strict inequality, so I'm going to make that a dashed line. Making that a different color so it shows up. So this blue line is at y equals 3. Okay. Again, I could either just go back and say, all right, this is y is greater than 3, so those points would be up here, or I can always use my test point, 0, 0, and say 0 is greater than 3. That is not true. So I know this is not part of the solution set, so I need to go up here. Okay. So again, the solution set for the system of inequalities is the area of intersection of the two solution sets. So for this first inequality, the solution set is over here. For the second inequality, the solution set is up here. And I can see the area of intersection is right up here. And it's to the right of this solid vertical line, and it includes the points on the line. And it is above the dashed blue line, and it does not include the points on the line. So just graphing each inequality and finding this area of intersection. Here, slightly more complicated, but same technique. Again, a system of inequalities, starting with the first one. Y is greater than x plus 1. The corresponding linear equation is y equals x plus 1. The y-intercept is 1, and the slope is 1. So increase y by 1, increase x by 1. Increase y by 1, increase x by 1. And this is also going to be a dashed line. Since it is a strict inequality, this boundary line is not part of the solution set. Taking a test point, 0, 0. Substituting back into that inequality to give 0 is greater than 0 plus 1. So that says 0 is greater than 1. Well, that is, of course, not true. Which means that this half plane, where the test point is not part of this, is not the solution set. Instead, it's the upper half plane. So I'm going to shade that in to indicate that this is the solution set for the first inequality. Second inequality, y equals negative x plus 2. inequality is y is greater than negative x plus 2. Corresponding linear equation is y equals negative x plus 2. So that gives me a y-intercept of 2 and a slope of negative 1. So decrease y by 1, increase x by 1. Decrease y by 1, increase x by 1, and on down. Again, a strict inequality, so another dashed line. Making this a different color so it stands out as a separate line. So this blue line is the boundary line for the solution set of the second inequality. Okay, again, using 0, 0 as my test point. Substituting into that inequality. 0 is greater than negative 0 plus 2. So 0 is greater than 2. And again, this is not true. So looking at this line, this point is not part of the solution set. So this lower half plane is not the solution set. I'm going to go to the upper half plane and shade that in. Okay, therefore, the solution set for the system of inequalities is right up here in this corner. It is the points above the black line, but not including this line, and above the blue line, but not including that line, that boundary line. Technique, again, graph the first inequality, which was right here, found the solution set in the upper half plane, graphed the second inequality, and found its solution set in the upper half plane, and then noted that this area up here is the overlap between the two inequalities, and that contains the solution set for the system. Okay, example 3, 2x minus y is greater than 4 is my first inequality. And one thing that I see right away is that this is not in the standard form we usually use. So I'm going to work with this to put it in the standard form where y is isolated on the left. And that's going to give me negative x is greater than negative 2x plus 4. Now, I have to divide by negative 1. And recall that when you divide an inequality by a negative number, then you have to reverse the direction of the inequality symbol. So this is going to become y is less than 2x minus 4. And it's absolutely crucial that if you're multiplying or dividing by a negative number, you immediately reverse the inequality symbol or you won't end up with the correct solution set. Okay, so that's my first equation. I'm going to go ahead and do that same thing with this inequality, with the second inequality before I work with either one of these. So here I have 4x plus 2y is greater than or equal to negative 2. So I'm going to subtract 4x from both sides. And then I'm going to divide both sides by 2. And since 2 is a positive number, I can just keep that inequality symbol as it was. So this is negative 4 divided by 2. So that gives me negative 2x minus 1. Okay. Looking at this first inequality, corresponding linear equation, now in standard form, slope-intercept form, y equals 2x minus 4. So by putting it in that form, it's much easier to graph. Y-intercept at negative 4, and the slope is 2x. So increase y by 2, increase x by 1 for the slope. Looking back, this is a strict inequality, so I need to use a dashed line, indicating that the boundary is not part of the solution set. And then a test point, because I need to determine where the solution set lies, in the upper or lower half plane. Using the origin, as my test point, substituting 0, 0 in for x and y. This gives me 0 minus 0 is greater than 4, or 0 is greater than 4. And that is not true. Since that is not valid, that is not part of the solution set, so this is not the correct half plane. I'm going to shade the lower half plane instead. Okay. Over here, the corresponding linear equation is y equals negative 2x minus 1. So the y-intercept is negative 1. The slope is negative 2x. So when I decrease y by 2, I'm going to increase x by 1. Decrease y by 2, increase x by 1. Again, I have to check here, and I see that I'm going to use a solid line for this boundary line because the line is part of the solution set. And then a test point here, and I want to pick a test point that's not quite so close to this boundary line, just in case my graphing wasn't perfect. So I'm going to select 1, 2, right up here as my test point, just to be safe. Substituting those values into this inequality right here, or back up here, either way. I'm going to go ahead and use this one because it's simpler. 2 is greater than or equal to negative 2 times 2 minus 1. 2 is greater than or equal to negative 4 minus 1. So 2 is greater than or equal to negative 5. And that is true. So my test point is in the half plane containing the solution set. So I'm going to shade this upper half plane. Once I've done that, I can see that the solution set for this set of inequalities, the system of inequalities, is right here. It is the area bounded by this line, and including the line, and then the area bounded by the dashed line right here, but not including it. So this lower right section of the graph. So for this one, we had to take an extra step just to make it easier, put this in standard form, and then graph the corresponding linear equation to find the boundary line. Use the test point to find that the lower half plane was the solution set for this first inequality. Same technique for the other inequality, and the upper half plane turned out to contain the solution set. So my area of intersection is right here. That is the solution set for the system. Okay, example 4. Y is less than 2x plus 1. Y is greater than or equal to 2x plus 3. Going ahead and starting out with the first inequality, y is less than 2x plus 1. Finding my boundary line, the corresponding linear equation, y equals 2x plus 1. Here, the y-intercept is 1. The slope is 2. So increasing y by 2, increasing x by 1. And continuing on. Checking back and seeing that I need a dashed line because this is a strict inequality. So graphing out this line with a dashed line. So this line will not be part of the solution set, the points on the line. Second inequality, y is greater than or equal to 2x plus 3. Linear equation, y equals 2x plus 3. I'm going to go ahead and graph this out. And this tells me that the y-intercept here is 3. And the slope is 2. Increase y by 2, increase x by 1. Or decrease y by 2, decrease x by 1, and so on. So this is going to give me another line right next to this one. But this time, I'm actually going to use a solid line. So this is a solid line because this is greater than or equal to. Now, let's look at some test points for each. So for this first one, let's use a test point of 0, 0, right here for this line. And substitute in. 0 is less than 2 times 0 plus 1. That gives me 0 is less than 0 plus 1, or 0 is less than 1. And that is true. So I've got this as part of my solution set right here. So it's the lower half plane. So I found the solution set for this inequality. For this one, I'm also going to use 0, 0. That's well away from that line. That's a good test point. Substitute in. 0 is greater than or equal to 2 times 0 plus 3. 0 is greater than or equal to 0 plus 3. 0 is greater than or equal to 3. That is not true. So for this line, 0, 0 is not part of the solution set. So it's the upper half plane. Now, a little tough to draw, but if you look here, one thing that you'll see is that these lines have the same slope. Because of that, I know that these are parallel lines. So I know these two lines are parallel and that they will never intersect. Since the points are all below this parallel line in that half plane and above this line that's parallel to it, these solution sets are never going to intersect. In this case, the solution is the empty set. There are no points in common since these are parallel lines. That concludes this session on solving systems of inequalities by graphing at educator.com. See you again.